I guess now our next speaker is going to be me. I will self-introduce myself here. My name is Jessica Torrion. I'm an associate professor here of crop physiology at the Northwestern Ag Research Center, but also the superintendent of the center here as well. My topic today is, it's a new thing that we have undertaken based on the demand of information for forages in Northwest Montana as well as in Montana as a whole. So today I will be looking at nitrogen and irrigation and also multiple species of warm season grasses. I will see and sharing my screen here. So first, I'd like to acknowledge my research team here. Amanda Shine did the bulk of this study, as well as our temporary research associate, such as Landry, who is in the audience today. Yusha is a postdoc research associate that just started also, that is helping me also a big deal with handling the data set. So our rationale really is that we are trying to integrate warm season forage grasses in our research, because this is another way of increasing diversity into our cropping system. And this is one that is not quite well established in terms of how we put this in our cropping system, and even an opportunity for an integrated livestock cropping system, which is a whole different level of research. Most of the topic that I'm going to present here is the effect on the levels of nitrogen input. This is one of an input that is still not quite known to us here in the Western region, as well as the levels of moisture, not just for yield, but also for quality, such as nitrates, carbs, crude protein, etc. So this year, this was planted late May as per industry recommendation. We just follow industry recommendation because that's what's available for us now, and we don't necessarily know when exactly was our best planting time. Early in spring, we did soil test, and there was 37 pounds per acre of nitrogen. So our goal is to have 5 treatments, one of which is to control, no additional N, which means only 37 pounds per acre nitrogen there. And we sum this residual plus what we applied here to come up with the 75, 100, 125, and 150 also. So we did 2 environments. This is a rather large study with 7 warm season grasses. So we have a pearl millet, we have a Sudan grass, this piper, and then we have 2 species of teff, and then a sorghum Sudan. Sorghum Sudan is a hybrid between, of course, sorghum and Sudan grass, and this has different photoperiod sensitivity. And this SS1 is intended so that we, the company didn't want to, basically this is a VNS, variety not stated. So the SS04 here is the longest maturing sorghum Sudan hybrid. So this is kind of the overview here. We have an irrigated block. We applied 5.8 inches. And in the rain-fed, of course, both of them received 6.7 inches in the season. So in each of those, there's a fertility level there, and the 7 species is randomized within specific fertility level. So this is kind of how it looked from a closer view, and this is Ben right here. And if you see, this is one of the sorghum Sudan grass that matured a bit later. And this is also the effect of an early frost in September. So if we happen to plant something like this, we probably don't have to wait for heading before we harvest them and make sure we escape from the early frost. So this is how it looks like. Here's Landry, and it looks like a corn, but maybe lower leaf area, but it's a lot of vegetation for sure. For this is the Sudan grass right here. Now, this one here is the yield is impacted by both the environment and end supply association right here. And if you notice, the maximum yield for irrigation is at 75 pounds total nitrogen supply. Adding more is not going to do anything anymore. The interaction here is very obvious in rain-fed, wherein if you apply more, the yield will get reduced in reference to the 75 pounds per acre. So that's kind of a very common thing in grasses too, where too much nitrogen that is not used, it accumulates in the tissue and it becomes a little bit of a toxic effect, especially for rain-fed. So that's counterproductive. So this is a yield on the environment and species interaction as well. If you notice, it looks like the effect on a different species is kind of similar, except the piper. The piper here in the rain-fed increased relative to the others compared to when it was irrigated. Piper has the same yield as the other Sudan grasses, but it remained higher in rain-fed, and Sudan grasses here is a bit lower, two of those species. So the next one here, the nitrate level, as you can see under irrigation, nitrate level increased as we increase our nitrogen supply, and that's just expected. The more water in there in the environment, the more plant takes up that nitrogen that's available in there too. And so in under rain-fed, no additional nitrogen uptake there in the tissue when nitrogen supply is further increased. So, but in general, irrigated environment would have more nitrate accumulation than rain-fed, which is expected. So when it comes to nitrate with species, pearl millet has the highest level of nitrate, and some of the sorghum Sudan grass too. Teff would have the lowest, less than 1,000 ppm. Crude protein here, that's kind of expected. The most crude protein we get is up to 75 pounds per acre of nitrogen supply, and no further increases beyond that too. This is a crude protein of the environment and species interaction. It's pretty similar, except there's a, I think one of the, the interaction is not very obvious here, but in general, there's more crude protein for sure in the irrigated. I know that in the rain-fed is a little bit reduced, but the pattern is kind of similar in terms of the relative difference between species. The water-soluble carbohydrates here, this water-soluble carbohydrates is what's the major component of your non-structural carbohydrates. So as you can see, it also is influenced between the irrigated and also species. So here to your right side here, I put here the reminder of the species of each of these entry here. So you can see that the water-soluble carbs of the sorghum Sudan is a lot higher compared to the rest. And also with the pearl millet as well. So the takeaway here, I really don't have much time either. So the takeaway here is yield in the warm season forage grass responded with an association between nitrogen and moisture levels. We saw in our slide before that 75 pounds N supply was the optimal supply for maximum yield under irrigation. Under rain-fed, we have to be careful that, adding more nitrogen is counterproductive. It actually reduces the yield if the total nitrogen supply is more than 75 pounds per acre. Sorghum Sudan species recorded better yields at any of the environments, both rain-fed and irrigated. Piper Sudan was also competitive. Maximum crude protein was also attained at 75 pounds per acre N supply. So this is also very common in grass species. You heard it earlier also that we have low protein when our spring wheat has a lot of yields. This is also similar in forage grass, where the higher the forage yield, the lower is our crude protein as well. So it's very common that we would have an inverse relation there between those two traits. Now, the water-soluble carbs tend to be higher under rain-fed, but much more pronounced in teff. Sorghum Sudan and pearl millet recorded with greater carbs in either of the environments. So as I said, this is kind of a nice option in terms of what we can do. I think our first year provided us a lot of data, and we measured a number of things within season 2 to document some of the yield components that is responsible for increased yield in some of the species. Again, if we plant some of the sorghum Sudan grass that has longer maturity, we may be able to harvest them ahead of time before frost. And with that, I would entertain questions.
So, Jessica, I have a quick question for you.
Okay, Treg.
Just curious, were you able to, on the sorghum Sudan grass, under irrigation practices, could you get 2 cuttings? Could you take an early cutting and then let it grow back and get a second cutting as well?
So yeah, so there was a little bit of regrowth on the Sudan grass. And so I think you could do 2 cuttings, but sometimes, it might not be worth it sometimes for our time and energy, gasoline-wise maybe. But there was probably, I would guess, a foot and a half of regrowth, and we decided not to cut it. Okay.
I have one more question to regard in both of them. So if you were and you had the choice to plant teff or sorghum Sudan grass for your rotation, what would you feel would be the better fit?
That's a really good question. That's a really good question. I think either of them would have a good potential. So I think with teff though, you would have multiple cuttings, and it would have been nice to have like an economic benefit of multiple cuttings and what you would spend in terms of your time and resources there, because you would end up doing multiple cuttings, and also the price too. I think within the limit, the time frame as well, I think it fits okay. You might be able to plant winter, if it's grass to grass, we might be able to squeeze in a winter wheat thereafter, or like a winter canola on teff if you don't want to cut any more cuttings on teff and you just want to remove it. That would be a possibility, but that's the function. That's Clint Byerman's research. I'm looking forward for him to evaluate this type of research too. The time
Jessica,
is, hello.
are all of these varieties that you tested commercially available to producers?
Yes, they are commercially available to producers. One of the company is Barenberg, and then the other one I believe is Alta for the Sudan grasses. I just shoot me an email and I will provide you a specific information about it.
Thank you.